If you've ever spent hours, and I mean hours, manually placing trees in a forest or duplicating windows on a skyscraper, you know the grind of 3D creation. It can be exhausting. But what if you could design a system that builds the world for you? Well, that's the absolute power of procedural generation. It's this game-changing approach that's no longer just for high-end studios. It's right at your fingertips in tools we all know and love, like Blender and Unreal Engine.
Okay, so let's really dive into this by first looking at a problem that, let's be honest, every single 3D artist eventually runs into. Whether you're building a massive forest or a sprawling city, placing every single object by hand, it's just a monumental task. This is what we call the creator's dilemma. How in the world do you build these vast, detailed worlds without spending endless, mind-numbing hours on repetitive tasks? So on one side of the coin, you've got the traditional, manual approach. It's slow, it's super repetitive, and honestly, it's rigid. If a director comes in and says, hey, make that forest about 20% denser, you could be looking at hours, maybe even days of rework. But on the other side, there's the procedural approach. And here, you're not placing trees, you're designing the idea of a forest. Need it denser? You literally just move a slider. The entire world updates in an instant, giving you this incredible flexibility and speed. It's a total game changer.
So what exactly is this powerful solution? It might sound all technical and intimidating, but really, at its heart, it's this beautiful place where creativity and logic collide. Let's break down the core idea because it's simpler than you might think. Here it is, plain and simple. Procedural generation is just using rules to create things automatically. So instead of hand-placing 500 rocks, you design a rule that says, scatter 500 rocks on this terrain, and hey, give each one a slightly different size and rotation while you're at it. See the shift? You're no longer just an artist making an object, you're the designer of a creative system. And the workflow itself is this really powerful loop. First, you define the rules, maybe using nodes or a bit of code. Then you feed it some parameters, things like how many objects you want or how much randomness to apply. The system spits out a result, and you can iterate almost instantly just by tweaking those inputs. And then finally, there's this super crucial step called baking, which locks in your design for maximum performance. We're definitely going to talk more about why that's so important in a bit.
Okay, so how does this abstract idea actually become a practical tool that you can use today? Well, let's look at how two of the biggest applications in 3D, Blender and Unreal Engine, are making this incredible power accessible to pretty much everyone.
First up, we've got the open source hero, Blender. Its geometry nodes system has been a complete and total game changer. It brought the kind of procedural power that used to be reserved for super expensive software like Houdini to literally everyone. It's a visual, node-based system, which means you can build incredibly complex logic without writing a single line of code. It's amazing.
So what can you actually build with this thing? Well, the most obvious use is scattering, instantly covering a landscape with rocks, trees, and grass. But it goes so much deeper than that. You can create what are called parametric models, like a spiral staircase where changing a single height value automatically adds the perfect number of steps. That same logic can drive complex motion graphics or even build out entire building facades.
Now, shifting gears into the world of game development, Unreal Engine 5 has its own incredibly powerful answer to this, the Procedural Content Generation Framework, or PCG for short. This system is built from the ground up specifically for creating vast, interactive worlds that need to run smoothly in real time. Now, a lot like geometry nodes, Unreal's PCG is fantastic for scattering assets. But here's the cool part. It's deeply integrated with the game engine's own data. You can actually tell it to only place trees on slopes that are less than 45 degrees, or to only spawn buildings in flat designated areas. It can even be controlled at runtime, which allows for worlds that can literally generate themselves while you play the game. How cool is that?
Okay, at this point, you're probably thinking that having a computer constantly calculating all of these complex rules sounds, well, like it would slow your machine to a crawl. And you know what? You'd be right. Running a dynamic procedural system in real time can be incredibly demanding on your hardware.
This is the #1 question everybody asks. How do you get all the amazing benefits of procedural flexibility without grinding your game or your animation to a complete halt? Well, the answer lies in a really crucial optimization step.
The solution is a process called baking. Just think of it like this. You use the super flexible procedural system to design your perfect world, tweak it until it's just right, and then, once you're happy, you bake that result into a simple, static 3D model.
This really means you get the best of both worlds, infinite flexibility during creation, but your final game or animation only has to deal with lightweight, super optimized assets. So this all comes down to working smart. After baking your geometry, you can use incredibly powerful techniques like instancing. Instead of telling the computer to remember 1,000 unique individual rocks, instancing basically tells it to remember one rock and just draw it 1,000 times in different spots. It is a massive, massive performance save. By combining these methods, you lock in all your complex, beautiful procedural results into assets that are incredibly fast and ready for your final game or render.
But here's where it gets really interesting. This procedural mindset goes way beyond just scattering trees and rocks. Once you start thinking in terms of rules and systems, you start to realize it's a fundamental approach that you can apply to almost every single aspect of digital creation.
Seriously, it's everywhere. You can create procedural materials in Blender that generate infinite variations of wood or marble textures without needing a single image file. You can drive animation with math instead of tedious keyframes. And in games, you can randomize things like loot drops or enemy placements to make every single playthrough feel unique. The logic is exactly the same across the board.
You know, this all comes down to a core philosophy, which this quote just captures perfectly: control through abstraction. You're shifting your focus, you're no longer micromanaging every single detail. Instead, you're designing the behavior, the system, the very rules that govern your entire world.
This right here is the key takeaway. We are in the middle of a fundamental shift in how we create, moving away from manually sculpting every single object to designing the intelligent systems that build those objects for us. It's a whole new way of thinking.
So this leaves us with a new and I think really exciting question. The challenge for the modern creator is no longer just what will you make, but what rules will you design? By embracing this way of thinking, you're not just making objects anymore, you're building entire worlds that can grow, adapt, and surprise you in ways you never ever thought possible.